All right. Welcome back to Math with Herlaar. This is our grade 9 video number 3. What we're going to do here is we're going to look a little bit closer at prime numbers, and then we're going to look at how prime numbers relate to lowest common multiple, which is always a bit of a point of contention. This is more of an extending grade 9 concept. It gets touched on again in grade 10, but we might as well look at it, give ourselves a bit of a challenge. So here we go. One question to ask yourself, and a question that people ask themselves, well, maybe not everyone, is this number prime? Because sometimes we look at a number and we go, well, it looks prime. And what does that mean? It ends in the 9? I don't know. But there is a very simple yet labor-intensive algorithm to determine whether or not a number is prime. And the reason why we can't just apply it to figure out what the next largest prime is because you'll see it takes a really long time. And you can imagine as those numbers get incredibly large, it would just take forever. But what it involves is first it involves understanding the factors. Because remember, forget 241 for a second. Remember when we had the number 36? Our factors were 1 and 36 and 2 and 18. And as we worked our way down here and we worked our way down here, we ended up with 6 and 6. And the square root of 36, which we're going to talk about in the next video, so I don't want to dive too deep into square roots, but you've seen square roots before, is the midpoint of the factors. So if you have a factor on this side of the list, obviously you will find its partner on this side of the list. So we only need to try dividing numbers by the factors on one side of their square root. And since, remember that composite numbers can be divided by primes, all we need to do is try to divide our given number, so in this case 241, by the prime factors on the one side of its square root. So if you just think about that with respect to 36, if I wasn't sure if 36 is prime, now obviously it's even, but the square root of 36 is 6. So if I wanted to test it, rather than try and divide 36 by everything, I only need to divide 36 by the prime numbers less than 6. So 2, 3, and 5. Because if my number is not prime, it will divide by one of those primes. If my number is prime, it won't. And that is how you find out whether or not a number is prime. And you can see in the case of 36, it's going to divide 2 and it's going to divide 3. So it's definitely not a prime number. Now, let's take the number 241 here for a second. Obviously, we don't know what the square root of 241 is. But if you can rattle off your perfect squares up to about 12 or 13, you're getting close. And again, the next video is going to be squares. I kind of poorly arranged this, so just bear with me here. 12 times 12 is 144. 13 times 13 is 169. And then, obviously, those are both less than 241. Well, 15 times 15 is 225. So it's getting really close. So you can assume, well, I mean, let's just do a bit of math here. Actually, there's a really cool trick with this. If you want to find the square root of something, and say here the number is 16, increase it to its highest tens, so in this case 20, and we went up by 4, so then go down by 4 here to get 12. Because 2 times a number is pretty easy. 2 times 12 is 24, and then plunk a 0 on the end. So 20 times 12 is 240. And then you take the value that you added and subtracted, and you square it. So in this case, 16, then you add that together, 256. That is what 16 times 16 is. Nice little math trick. It's bonus. Welcome to Math with Herlaar. I throw those in all the time. So we can see now that 241 is basically in between 15 and 16. So you got to try numbers below 15 as factors, and you only need to try primes. So 13, 11, 7, 5, 3, and 2. And remember that we have divisibility rules for numbers like 2 and 3 and 5. So if you look at 241, does it divide by 2? No. Does it divide by 3? Well, 2 plus 4 is 6 plus 1 is 7. And if you can't remember this, remember to click back and watch the first video on divisibility rules. No. Does it divide by 5? No, because it doesn't end in a 0 or a 5. And then when you get to these last 3, you just got to try them. And you could try them using your short division. So here we take 241 And we try and divide it by 7. Well, 7 goes into 24 3 times with 2 remainder. 7 goes into 21 7 times. Oh, so there we go. 241 is divisible by a prime. It's divisible by 7, so it is not prime. Now, this example, the number is quite large. I did a couple smaller examples here next so you can see it in action with smaller ones. So, is 57 prime? Well, the square root of 57 is going to be a little bit less than 8 because 8 times 8 is 64, right? So let's try prime numbers below 8. So we need to try 7, 5, 3, and 2. Well, obviously 57 is not divisible by 2. It's not even. But what's 5 plus 7? It's 12. 12 is divisible by 3. So we get 57 is not prime because it's 3. 3 goes into 5 once with 2 remainder. 3 goes into 27 9 times. So 57 is not prime. What about 343? Well, again, this is a large number, so knowing your squares helps. 20 times 20 is 400. So even if you're not sure anywhere around there, just take 20 as your starting point and go prime numbers below 20. Well, 17, 13, 11, 7, 5, 3, and 2. It's not even, so goodbye 2. 3 plus 4 is 7, plus 3 is 10, so not divisible by 3. Doesn't end in a 0 or a 5. Okay, so now we get to, we just have to try these last few. So is 343 divisible by 7? I don't like the red, but I'm going to finish with it. 7 goes into 34 4 times with 6 remainder. 7 goes into 63 9 times. So 343 is 7 times 49, also not prime. All you got to do is find one prime factor and you know the number isn't prime. Now again, this is bonus. This is more deeper understanding of primes. Don't stress out if you can't quite grasp this right away. You'll see it again in grade 10. But try, practice. It's about factors and about square roots. So after I post the square root video, which I believe is the next video, I'll put a link at the end of this video to it, or at the beginning of this video. You can actually watch it first and then come back to this. Now, lowest common multiple. A lot of people get this confused because they see the word lowest and they think the number has to be small. And that couldn't be further from the truth because the most important word here is multiple. You are looking for a multiple of each of these numbers. So what are the multiples of 12? 12, 24, 36, right? That's 12 times 1, 12 times 2, 12 times 3, right? Those are multiples. And then what are the multiples of 30, 30, 60, 90? So 30 times 1, 30 times 2, 30 times 3, and then the multiples of 50, and I see you get the point. So you can imagine there's no way that the lowest common multiple can actually be anything less than your largest number because it needs to be a multiple of all of them. So 50 needs to exist. So here's what we're doing. We're creating a new number, the lowest common multiple. And what it has to have is it has to have the factors of every of the existing numbers. Because in order to be, let's look at 12. 12 is equal to 2 times 2 times 3. So in order to be a multiple of 12, you need to see that prime factorization in the new number. So that right away tells me that in my lowest common multiple, I need 2 times 2 times 3 because that's 12. So if I'm going to be a multiple of 12, I need 12 in there. So there's 12. What's 30? Well, 30 is 2 times 3 times 5. So in order to be a multiple of 30, I need 2 times 3 times 5. Now, if you look, I already have 2 times 3. So the only thing I need to include is a 5. And now what you'll see here is you have, I'm just going to erase the blue here for a second. It's going to erase everything, so I'll throw the rest back in there. 2 times 3, or 2 times 2 times 3. So you can see in that number that is being created, here is 12. So far my lowest common multiple is 12 times 5. Here is 30. So my lowest common multiple is 30 times 2, but I still need 50. So what's 50? 50 is 2 times 5 times 5. So you can see I need 2 5s and a 2. I already have 2 2s in there, so 2s are covered, but I need one more 5. So I need to bring one more 5 to this party, and now you can see that I have 50 right there, and it's 50 times what's left, 6. So my lowest common multiple comes back 2 times 2 times 3 times 5 times 5. Well, what is that? Well, 4, 12, 60, 60 times 5, 300. But the prime number expansion is good enough. But you can see that each factorization of all three of the numbers, each prime factorization, is in that representation of your new number that you've created, your new multiple. So let's look at another example. 8, 12, and 18. So I'll show you another way to look at this. I need 8 to be represented, so I'm going to need 2 times 2 times 2, and if you consider exponents, which we'll look at in a few videos, you can always zip ahead once those videos are posted. 8 is 2 to the power of 3. Now 12 is 2 times 2 times 3, so what you get from 12 is you get 2 squared times 3. And then 18 is 2 times 3 times 3, so you get 2 times 3 squared. So if you consider the fact that your lowest common multiple has to have each number represented, put a little rectangle around all of your columns of different primes. Now, if you had a 5 here, you'd make a column with 5, but we don't have that, right? So keep them lined up. And look through your column and say, okay, well, obviously, in order to be a multiple of 18, I need 1 2. In order to be a multiple of 12, I need 2 2s. In order to be a multiple of 8, I need 3 2s. So if you need 3 2s to be a multiple of 8, well, obviously, if you have 3 2s, you have 2 and you have 1. So you need to bring the largest number of times a factor occurs. So I need 2 to the power of 3 in my lowest common multiple. In order to be and 8 is covered. In order to be a factor, a multiple of 12, I need a 3. In order to be a multiple of 18, I need a 3 squared. So obviously, I'm going to need to bring a 3 squared. And there is my lowest common multiple. 2 cubed times 3 squared, which means 2 times 2 times 2 times 3 times 3. Again, if you're unsure about exponent work, there will be an exponent video you can rip up to, but at this point, exponent basics were covered in earlier years, middle school, elementary school. Don't feel bad if you don't quite remember or you're shady on it. Just watch the video on exponents or just make sense of it now. It just means repeated multiplication. So 2 times 2 times 2 is 8, 3 times 3 is 9, so our lowest common multiple is 72. I think I got one more here. No, that's it. So we're going to do, as mentioned, there's going to be a video on squares, square roots, and Pythagorean theorem, so we'll go a little bit more in depth than just knowing what a square root is, because again, I think that at this point, hopefully you understand basic square roots. If you want to see a video on square roots or basic exponents, throw it in the comment section and I'll get that up for you. But I hope this helped. Again, this was an extending concept, lowest common multiple, and determining whether number's prime. So don't feel bad if this was a little bit over your head. You will see it again in grade 10. Best of luck. Keep learning, keep trying, keep practicing. If you screw up, figure out what went wrong. That's the most important part. That is learning. Thanks. Take care, everybody.